right, so this video we're going back to Algebra 1 and we're reviewing a really core Algebra 1 skill, factoring. So first rule of factoring, always look for the greatest common factor, the GCF. So when I look at this first problem, this expression, I'm looking at the biggest number that I can divide out of both terms and the biggest amount of variables as well. So if I look at the numbers first, right, what is the biggest number that these are both divisible by? So both of them, the 4, the 24, you could divide out of 4. Here I have an x to the second power, x to the first. I can divide out an x. Okay, what would I be leaving behind? So 4x squared divided by 4x, leaving behind x. Okay, negative 24x divided by 4x is just minus 6. Okay, always double check. So if I distribute back, this is 4x squared minus 24x, right? It restores me back to that standard form. We want to look at it factored. Okay, next one, look at the expression, look at the two terms. What is the biggest number you can divide out of both? They're both divisible by 16. How about the variables? X to the fourth, x to the first. So you can divide out a 16 and then x. So if I divide that 32x to the fourth by 16x, I'm leaving behind 2x to the third. Okay, and it's going to be a minus. So negative 16x divided by itself, just minus 1. Okay, multiply it back. There's my 32x to the fourth minus 16x. Okay, next pattern we look for is a difference of two squares. So here we have an expression where we have a perfect square minus a perfect square. It always factors into this binomial, x minus y, times this binomial, x plus y, where they're opposite signs. Okay, one thing to point out while we're here also is that there is no sum of two squares. So if I tried to factor x squared plus y squared, it does not become x plus y times itself. I always get that question. If I tried to multiply this out, if I tried to FOIL it out, watch what would happen. Right, I'd have my first, I'd have x squared, my outer, xy, my inner, also xy, and then my last would be y squared. Right, so there'd be some meat in the middle that we are not seeing here. So we cannot factor this. This does not become x plus y times itself. Right, that multiplies out to be this structure here, which if I go one more step, would be 2xy in the middle plus y squared. All right, so let's look for a difference of two squares. So over here, perfect square, right? This is x, quantity squared, 8 squared. Great. So when I write it, it's going to be x minus 8 times x plus 8. The order you write these doesn't matter. And then that's it. If I wanted to double check it, I could FOIL it out. Right? X squared plus 8x minus 8x. Those are opposites. They knock away. Okay, negative 8 times positive 8. There's my negative 64. So that holds. Okay, over here in 4, perfect square. This is 3x, quantity squared, and 1 squared. Fits the pattern. So 3x minus 1, 3x plus 1. Okay, next up. Okay, perfect square, perfect square. Right, I can see that this is 5x, quantity squared, 9 squared. Okay, so then I can break it up. 5x minus 9, 5x plus 9. And again, the order doesn't matter. And if I wanted to double check, first, there's my 25x squared, outer, 45x, inner, minus 45x. So that middle piece, right, that linear term, those were opposites, they knock away. And then the last is that minus 81. So we're doing good. Okay, this last one here, meant to be a little bit more challenging. So here, x to the 4th, that's still a perfect square. Right? If I said, what is the square root of x to the 4th? That's x squared. So this is x to the 2nd power squared. 625 is 25 squared. Okay, so I've identified my perfect squares. So now I can break it up. X squared minus 25, x squared plus 25. All right, let me stare at that for a second. Am I done? So remember that right here, that's a sum of two squares. I can't break that down further. But over here, that is still a difference of two squares. Right, that's x squared, 5 squared. So I can go one more step right here. X minus 5, x plus 5. And then I'm leaving behind the x squared plus 25. Nothing else I can do. And again, all these packages could come in any order. We'd be equally correct. Okay, lastly, looking at basic quadratic trinomials. So basic, because we're saying that the a value, the leading coefficient, in front of the x squared, the quadratic term, right, is just 1. And there's 3 terms, trinomial. All right, so when I look at this first one, in my head, what I'm thinking, guess and check, is, well, gosh, what multiplies to a negative 24 that adds to a negative 5? Now, some of you are visual, and you like to see it. So I usually draw out a little cross where P is my product, right? What do I multiply to? S is my sum. What do I add to? And my product is always the A times the C. The A times the C. So 1 times the negative 24. Okay, my sum is the B. Right, the B. So negative 5. Okay, so two numbers that multiply to 24, negative 24, that add to negative 5. Well, I know that 8 and 3, right, that makes 24, but I need it to be negative, so 1 has to be negative, and it has to add to negative 5. So it's got to be the negative 8. So x minus 8 and x plus 3. Again, any order is fine. All right, this very last one, well, look at it for a moment. Is the A value 1? I'm being a little sneaky here. The A value is not. The A value is negative 1. So that means that you have a GCF to deal with first. Right, that negative 1 is a GCF. Divide it out first. So if I divide out a negative 1, from each of these terms, all of the signs flip. So I now have x squared plus x minus 56. Okay, so now I'm looking for two numbers that multiply to negative 56 that add to a positive 1. Let me help you visualize it. Product, sum. Again, A times C and the b. So 1 times negative 56, negative 56, and the b is just 1. Okay, so I know that the numbers have to be really close to each other. It's just that one is positive and one is negative. So 8 and 7 feel good, right? But one is positive, one is negative, and it has to be a sum of 1. So that 7 must be my negative. So when I write my answer, the negative 1 has to go first, but then it doesn't matter where you write the x plus 8 or the x minus 7. These could be flip-flopped, but that negative 1, right, just the negative reads as negative 1, that goes first. All right, so again, factoring is a huge Algebra 1 skill. We're going to keep circling back to it throughout the geometry year. Have a good day.